Alrighty, so we have a couple boxes left. Couple problems to number 10. So number 10, the first thing we got to do, well, first of all, remembering from yesterday, is this one going to be growth or is this one going to be decay? I heard both answers. Let's go. Okay, so I heard the correct answer, I heard the wrong answer. So let's look at what we know about it, right? We look at B, right? B is the guy with the exponent. Whoever has the exponent, we look at. If B is bigger than 1, it's growth. If B is smaller than 1, it's decay. Okay, so let's look at it again. 2/3. 2/3 has the exponent, right? 4 doesn't have the exponent. 2/3 is smaller than 1. 0.6666 forever, ever. If I put it in my calculator, okay? So it's going to be decay. Good. Okay. Decay. All right. Okay, so before we fill out the rest, let's fill out the table. Okay, so -2 is going to take the spot of x. So it's going to be a -2 here. And then a -1. Then a 0. 1. Oops. 2. Okay. I'll let you guys write that down before I go to the next. So we have a fraction to a power, right? We don't multiply the 4 yet. We always do exponents first. So let's start with the positive ones. Ones on the 1 and 2. 1 and 2 are positive. So remind me again, what is the rule when we have a fraction to a power? Distribute the power, right? Distribute the power. So that's what I'm going to do. I'm going to distribute the power. So when I distribute the 2, I'm going to give a 2 here and a 2 there. So when I do that, what is it going to equal? 4 over 9, right? 4/9. Okay. Now we bust out the calculators. 4/9. My calculator doesn't do fractions. Most calculators don't. So let's change 4/9 to a decimal. Okay, so let me get my decimal out here. Okay, so 4/9 is that decimal there, 0.444, repeating it forever and ever and ever. Okay, so we're going to go that number times what? Times 4. And I get 1.77777777 forever and ever and ever, or all the way to here where there's a 6. So I'm just going to go 2 places. So if I were to round this, 1.78, good, 1.78. Okay, 1.78. What happens if I distribute a 1 to 2/3? What's going to happen to it? Stays the same, 2/3, right? So now I'm going to go 2/3 times 4. Okay, so let me go back to my calculator. 2 divided by 3, 0.6666 forever and ever and ever. The reason why there's a 7 at the end is because my calculator said I'm not going to write any more 6s. I'm just going to round. Okay, so if I had a calculator long enough, this guy would just have 6s all the way to the end of time, right? But my calculator said that's as many numbers as I'm going to write. I'm just going to round the last one. Okay, so now I'm going to multiply that times 4. 2.67. 2.67. Okay. The next one, 2/3 to the 0 power. We like things to the 0 power. Why?
That would turn that fraction into 1, and
It,
if you multiply it by 4, it's just
Exactly. We like things to the 0 power because the 0 power just makes them a 1, just a 1. So that thing, that fraction is just a positive 1. Okay. So you're starting to see something, right? As I'm going up, what's happening to my y values? They're also increasing, right? So as I'm going, what the hell? If I'm going down, they're decreasing. Okay. All right. So let's go 2/3. What about 2/3 to the negative 1? What happens when I have a negative 1 power? They're going to end up flipping, right? Because when I distribute, I'm going to have that, right? And what does that mean? That means the 2 goes down, the 3 comes up. So yeah, it's going to be 3 over 2. 3 to the first, which is 3, 2 to the first, which is 2. So really anything to the negative 1 just means flip. That's all it means, just flip. Okay? So anytime you have anything to the negative 1, it just means flip it. Okay? So 3 over 2. 3 divided by 2. 1.5 times 4. 6 whole. No decimals, just 6. Okay. One more, and then I can go graph. Negative 2. Negative 2. So I have negative 2 here. Oops, I don't want that whole thing. I just want this guy here. So each of them is going to get a negative 2, right? Flip. So now that's going to be 9 over 4. Okay. Go to my calculator. 9 divided by 4 equals 2.25. Times 4, 9 whole. No decimal. Done. Okay, so let me go make dots. We already kind of know what it's going to look like. We know it's going to be decay. We said that earlier. We're just verifying it. So let's start. Negative 2, 9. Left 2, up 9. Negative 1, 6. 1, 2, 3, 4, 5, 6. 0, 4. 1, 2, 3, 4. 1, 2, a little over 2, not quite 3. And then the last one is a little over 1, almost 2. Okay. Horizontal asymptote. Where is the hard floor? So here's my question. Is this guy going to pull up like this, or is it going to continue down like this? Is it going to go like 0? Is it going to keep going down here to the negatives? What was the trick we used last time? There was a trick that I showed you guys on this problem here. When do we know? How do we know by looking at the original function, the original equation, where the floor is going to be? Exactly. The plus or the minus, right? The plus or the minus part. This one is negative 2. So that's how we knew that the floor was at negative 2, right? What does this one have? Nothing. It has a 4, right? But that's not a plus or a minus 4. That's a times 4. We don't look at that one. We look at the plus or the minus here. And there's nothing here. So that means it's going to be 0. That means the floor is going to be 0. So that means it's going to continue like this. Okay. Y-intercept, where does it cross? 0, 4. Just look at your table, or you can look at the dot on the graph for that one. Domain, what did we say about the domain? It's always going to be Yep. For these guys, since they all look pretty much the same, it's going to be negative infinity to positive infinity. Okay. Last one is range. Range is floor to ceiling. Well, where did we say the floor was? 0. What's the ceiling going to be for this guy? It's not going to be a ceiling, right? I can't possibly put a ceiling because that blue dot, or that blue arrow, this blue arrow is going to bust through it every time. So if there is no ceiling, you guys said it, it's just going to be positive infinity. Okay. All right. So what I want you to do is I'll give you guys about 5-7 minutes. I want you guys to do number 11. Do number 11. Okay. Plug in the values and then fill in each of the tables. Okay, so I know you guys aren't done, but I'm just going to kind of get started just in case you're stuck at all. We got a lot of things going on here. We have multiplication, 1/2 times. We have exponents, and then we have subtraction, right? -3. PEMDAS, right? Please excuse my dear Aunt Sally. Which one do we do first? Multiplication, exponents, or subtraction? Always exponents. Yeah, always exponents. So this is the guy we're going to focus on first every time. That's the guy we're going to focus on every time. Okay, once we do that, then we'll do multiplication, then we'll do subtraction. Subtraction's always going to be the last thing. We're always going to do -3 at the very end. Okay? So here we go. Let's start with the easy ones. So 4 to the second power is 16. 1/2. My calculator doesn't do fractions, so I'm going to change 1/2. What can I change 1/2 to? 0.5. Good. Times 16 is 8. And then I'm going to take away 3. I get 5. Okay, so this guy is 5. It's my first dot. 2, 5. My next dot. 4 to the 1 power. 4 to the 1 power is just 4. So I'm going to go 0.5 times 4. Oops. Which is 2. And then I'm going to go -3. That's always the last thing I do. I'm going to get a negative. -1. Okay. 0 power. We like 0 powers because anytime you have anything to the 0 power, that's just another way of saying 1. So I have 0.5 times 1 -3. -2.5. Now we have the negative exponents. The negative exponents. Anything with a -1, anything to the -1 power just means you're going to flip it. So if I flip 4, what is it going to become? What happens if I flip 4? 1/4, yeah. 1/4, that's all it's going to be. It's going to be 1/4. And what is 1/4 as a decimal? 0.25. So what I'm going to do is I'm going to go 1/2 times 0.25. So 0.5 times 0.25 -3. 0.25 times 0.5 equals -3, -2.88. I'm going to round 2 spots, -2.88. Okay. Now this guy right here is to the -2 power. The -2 power means I flip it, but then it still has the squared, right? So that one's going to be 1 over 16. 1 over 16. 1 over 16, if I divide that, 1 divided by 16, that's 0.0625. I'm going to multiply that times 0.5, subtract from 3, and I get a number that's very, very close to negative 3. Negative 2.97. Negative 2.97. Okay, make dots. 2, 5. I'm going to start at the bottom. So 2 comma 5. 4, 5. 1, negative 1. 0, 2.5. Negative 1, almost 3. The last two are going to be almost 3. Okay. Okay, that one's growth. Where's the hard floor? Negative 3, right? Right here. And it kind of shows on ours right here. It's not going to go past negative 3. Y equals negative 3. The y-intercept, 0, comma 2, negative 2.5. The domain is the same. The range goes from floor to ceiling. Floor to ceiling. Well, we know the floor is at negative 3. And this one, the red arrow is going to go through any ceiling that I put. So it has no ceiling. Infinity means it has no ceiling. Okay. Okay. So now, in lieu of the delta math that we usually do, I made a worksheet. These are delta math problems, but I only gave you 6 compared to what you normally have, so it's a little bit less. And we'll do one together. You guys take a look at it. Which one do you want me to do? Take a look at it. There's 4 on one side, 2 on the back. Pick which one you want me to do. I'll do one of them. You'll do the other 5.